Good afternoon.
Yeah, good afternoon. How are you?
Fine. I have a small question.
Okay.
Is it right that the midterm will be 8 chapters?
Yes. Yeah.
Oh, okay.
It is from the chapter 1 all the way up to chapter 8.
And we have almost 2 weeks left.
Yeah, 2 weeks left. So today we are finishing chapter 6. I will be doing the problems. So 6 chapters are done. And next week we will cover chapter 7 and part of chapter 8.
Okay.
Yeah. Yeah. So a week after that, everything will be done. Yeah.
Doctor, we had exam from chapter 1 to 4. Why we have from 1 to 8?
That is called coordinated test, coordinated exam, which was not there beforehand. Like just because of the pandemic, we brought this in the semester in the second semester of last year, since March. So that's
12 hours.
yeah, yeah.
Is it multiple choice?
What is that?
Is it multiple choice?
Yeah, it will be the same like as you guys has experienced the coordinated exam, so it will be like that. But now you all know that it will be physical, so somewhere in some centers, right? Whichever you have chosen.
Doctor,
Yes.
I say 8 chapters very short. Why not let it 15 chapters?
The final exam will be in the 15 chapters.
No, let it this one too. It's,
It's not our choice. It is there in the curriculum. So we cannot do anything about that, right? It's whatever the university has regulated, that's what it is going on. Okay. Uh, Let me start the problems, and then if you have any question, we can certainly discuss afterward because there is 1 hour office hour today. So remember that we were discussing the uniform circular motion, and that was like let me just go over a little bit quick review over this. Uniform circular motion, that the objects that move in a circle, but in this time it could be in some way in contact, like the gravitational force, for example, or the frictional force that is keeping the cars in the track, and also the tension force if something is tied to a string and someone is rotating it. So different kinds of force, the names of the forces can be different, but and overall we are calling it centripetal force. So these were the forces that we had discussed in the previous lecture, and then we did some problems on this. Today I'm going to continue doing some problems on that again. So this example is a race car of mass 600 kilogram runs on a flat track in a circular arc of radius 100 meters. Because of the shape of the car and the wing on it, the passing air exerts a negative lift downward on the car. The coefficient of static friction between the tires and the track is 0.75, and assume that the forces on the four tires are identical. If the car is on the verge of sliding, this is important sentence, on the verge of sliding out of the turn when its speed is 28.6 meter per second, what is the magnitude of the negative lift acting on downward on the car? So remember this sentence, I discussed it, like whenever you are saying that at the verge of sliding, it means that you are talking about the maximum static friction, and therefore you can use the formula for the static friction. Okay, so look at the board here, that this is the car as it goes in the circle, as it is shown in the diagram, like this is the kind of circle that the car is. Okay, so since there is the static friction, which is keeping the car in track, so the static friction is pointing towards the center, and that is the maximum static friction in this case, as they described it. And we also know that there is a centripetal force, because this friction force is producing a centripetal force, and that is equal to mv squared by r, right? That's what it is. Now, we also know that when the car is on the track, the weight of the car is downward towards the earth. So that is the mg, is the car weight that is downward. But also, this is not just a normal economy car. It's not a Toyota car type, right? They are saying it is a racing car. So there it is designed such that maximum air pass on top of the car. So when the maximum air pass on the top, the car will be pushed downward. So the more speed you gain, the car will be more getting towards the sitting towards the road. So the negative left is also downward just because of the car. So FL, we are just naming that in that form. As a reaction of these two forces, there is the normal force Fn, and that is upward. So now let's analyze the forces. How many forces we have? We know that the static fraction is equal to mv squared by r. That's one thing. If it was any speed, then we can say that the static fraction is any static fraction, right? But since they are saying it is at the verge of sliding, therefore we are going to use this as a maximum static fraction. And for the maximum static fraction, we know the formula mu s Fn. That was the formula that we had derived before. So we are going to use that. Just combine the equation 1 and 2. What we get is that the mu s Fn is equal to mv squared by r. So this is our equation 3. Now, the thing which we don't know here is that how much is the normal force. So the normal force is coming from the y-axis. Just put again like Fn positive minus FL negative minus mg negative. And since the car is not moving, accelerating upward or downward towards the earth, so therefore the net acceleration along that direction is 0. So the Fn is going to be equal to FL plus mg. Okay, so this is our equation 4. What we will do, we will put equation 4 and equation 3, ms FL plus mg equal to mv squared by r. And now they're asking that what is the magnitude of the negative left? So we need to work on this equation in order to isolate this FL. Okay, so I will divide both sides by mu s. Okay, and then I will be subtracting this from the both sides. So FL is equal to mv squared by mu s r minus mg. Now at this point we need to look at all the available variables, and if we know it, then we can leave this equation here. Mass of the car, do we know it?
Yes.
Yes.
Okay, and how about the speed?
Yes.
Yes,
Okay,
we
mu
know.
s.
Yes, we know.
Yes.
Okay, and the radius?
100.
Yes.
Yes.
Yeah, it's all given. So everything what we can put, the g is constant, so everything else is given. We can determine the FL, which is equal to 660 Newton. 660 Newton, that is the FL. Now there are two more interesting questions here. They are saying that what if the speed was increased? What will be the left? So the more the speed increase, the negative left will be increased accordingly, because the FL is proportional to the square of the V square. The V proportional to V square. So therefore, more speed you are getting, the more negative left you will have. The last one, it is more interesting question. They are saying, can this racing car be ever able to go upside down, like you are driving the car on the top of beneath the roof, like on the top this here? Can it go up like that? And answer is yes. Theoretically, it is possible, because if your car is getting the speed FL such that it can beat up the gravitational force, then yes. Like for example, you are seeing the gravitational force is 5,880 Newton. But if the car was going with the 90 meter per second, the negative left is 6,600, which is more than the gravitational force. So with 90 meter per second, if the car is going, yes, it will be able to stick with the rope and go like that. Okay, this is another scenario for the civil engineers when they are designing the roads. They are kind of providing a little bit support. They're just not only relying on the friction, but also they are banking it. So the banking road means that when you are tilting the road, like if this was the curve and you are having the providing some inclination in that. So this is the equation like that. A car of mass m moves at a constant speed, 20 meters per second, around a banked circular track of radius 190 meters. It is a normal car rather than a race car, which means that any vertical force from the passing air is negligible. So the negative left is not there now. And also, if the frictional force from the track is negligible, two things we have eliminated here: negative left and the friction between the car and the tires, okay, in the road. So these two things we have eliminated. Now we are just relying only how much the road has to be curved. So if the frictional force from the track is negligible, what bank angle prevents sliding? So look at the diagram once more, and whenever you are solving this kind of problem, always create this kind of inclination. Here you have this theta, and consider your car is like a block on this track like this, okay? Since we are very familiar with the track solutions, like when we are putting this in the form of the inclination, we know there are several forces and we need to resolve them. First of all, there is the weight, which will be downward, and then there is this theta it is making. So we have mg cosine theta here, and this one is mg sine theta. So these are the two forces you got from the just resolving the weight in two components. And it is as a result of the mg cosine theta, there is Fn, right? Upward. So this is one way of approaching to this problem. Like when you are putting this Fn is equal to mg sine theta, and then you are solving the problem in this form. Okay, this is one way of approaching, which was our traditional way of approach to it, right? Like in the previous cases, we have applied this method. And it is, you can also now successfully you can apply this. But there is one more trick to it, and which makes the problem even more easier. And let me tell you that if this is the same angle, the car is like a block, okay? And here you have this weight. The weight is downward, okay? Now, the normal force, we know it is upward to the track, Fn. I want to resolve the forces, the normal force horizontally, vertically, and horizontally. So I'm putting this as Fn, and this is the angle. So this will be Fn cosine theta, and this will be the Fn sine theta, okay? So since you know that this is just directly going towards the center right here, because this is making 90 angle, so this will be just directly toward the center. And this is basically the centripetal force which is keeping the car in the circle. So what I will do is, I will know that the Fn sine theta is giving me the centripetal force, which is the mv square over r. This is my one equation. And the second equation I'm getting is that the normal force component opposite to the weight is Fn cosine theta. Fn cosine theta is equal to mg. This is my second equation. If you got confused like why it is like this, then always remember that the Fn cosine theta is to the positive y. It is positive. This mg will be negative, and since the car is not accelerating vertically, therefore it is 0. So then I just rearrange this equation. Fn cosine theta is equal to mg. Okay, that's what I got. Now here we know equation 1 and equation 3. All we need to do is to divide equation 1 by equation 3. Okay, so by dividing that, the equation would look like this. And we know Fn is common, it cancels out, and sine theta by cosine theta is equal to tangent theta, and here mass and mass cancels out, and we left with the v squared by gr. Okay, so theta equal to tangent inverse v squared by gr. Okay, now again we look at the available parameters. If we have everything, then we can easily determine theta. Do we know the speed of the car?
Yes.
Okay, how about g?
9.8.
9.8, and r?
It's 190.
Yeah, 190. So everything is known. Just put them in. That will be your equation for solution for this. Okay, that will give you theta. So this was the sample problem, and look at this one. I'm not going to solve this because it's, of course, it's exactly the same problem. But here I'm pointing something out here. This question 20 is an exam question. And it is exactly the same like which I've solved. This is exactly the same problem. But read the statement. A highway curve has a radius 100 meter and is designed for a speed 50 km per hour. At what angle should the curve be banked car round the curve with nuts without any slip? The problem in this question is they are not talking about the friction at all. If you go back to the previous statement, you will be seeing they are saying the negative left on the car is 0, is negligible, and there is also no friction between the car tires and the road. Okay. In this problem, they did not specifically mention it. So the problem statement is a little bit poor on that side, okay, because it confused the students. But if you ever come into this and you see that the fraction was not mentioned and not brought into the discussion, just go ahead with the same sets of solutions. It will be just such that the problem is just a little bit poorly written. It's not kind of control statement there, okay? But the rest, the problem solution is the same like which I saw. Yeah.
For the friction and for and for the lift.
Yes.
For the race car. Yeah.
Yeah. Like if you are driving a truck, then there is no negative lift. It is almost negligible in that. Are just economy cars, so it's negligible. So which we usually buy, right? But the friction is another thing, which is always there between the tires and the road. Okay, so with this, I'm ending the lecture from the main slides, but we're beginning the solution from the, where is that, guys? Okay. Let me go back to the problems. Where is it? Recitation. Okay. So these are the problems from the same chapter, chapter 6. In this problem, as shown in figure 7, a block mass A, 2.3 kilogram, rests on a horizontal rough surface, mu k. When they give you the mu k, it is implied that there is some motion, right? Okay, and mu k is 0.45. It is connected by a horizontal cord passing over a massless, frictionless pulley to block B, which is 1.3 kilogram. What is the magnitude of the acceleration of the system? So this is very similar problem that we had been solving in chapter 5, but now, of course, in chapter 6 there is a frictional force. So let's draw this diagram. There is this pulley, and here is the mass attached on this side. This mass is called B block, and this is called A block, okay? Block A. And this is in contact with the rough surface. And there is a mu k means that the block is already in motion. So we are resolving the forces in the same order that we are saying that the block B is downward, so MB G is downward, tension in this is upward. And again, tension here is to the right. And since this is moving in this direction, so the fractional force will be appearing opposite to the motion of the block. Okay, so then the Fk is to the left, and we can assume that the block, this block is coming downward. Acceleration direction is this. So similarly, acceleration direction for the block A is to the right, because both of the blocks are connected. So the acceleration should be in the same order. Now solve the problem for this block A. Okay, block A, and we also know here that the block A has mass. Due to the mass, there is a weight, right? MAG, and as a result, there is a normal force Fn on the block. Okay. Now let's resolve the forces along x-axis on the table. T is to the right side, right? Fk is to the left side. So therefore it is negative, T is positive, and it is as a result of these two forces, the block is going to the right side. So it will be Ma with acceleration A. This is equation 1. Now, we also know that the equation for the kinetic friction is, can someone tell me what is the equation for that?
Mu k multiplied by F normal.
Okay, so mu k times Fn, and how much is Fn from this diagram?
Mg.
It is equal to mg, so mu k mg. This is our equation 2. We put this equation 2 here, okay? So it will be T minus Fk. So for the Fk, we are putting this mu k, and this is of course the block A, so mag equal to maa. This is our equation 3. Now we know this for the block A solved. We come to the block B, and it is clear, it is easy, exactly the same as in equation as in chapter 5, because there is no friction involved. So T is up minus mbg is down, and it is still going downward. So mba with acceleration. Okay, since they're asking us to determine acceleration, and we have two unknowns, one is the acceleration and another one is the tension. So we are of course going to subtract equation 4 from this equation. So when we are subtracting this, the signs will be different. It will change like this, and then we are adding them. So the TT is cancelled out. We will be left with mbg, okay, minus mu k mag, okay, and on right side we get two masses, ma plus mb, and times acceleration. If you are happy here, then we can leave it and just accept that it is the solution, because the block B mass it is given to us, block A mass it is given to us, G is constant, mu k it is 0.45, it is also given. So again on the right side there are two masses and we know them. So everything is known in this problem and we can leave them here. Do you have any question? Guys, ask questions. If you are confused at any point, just ask question. Is it clear?
Yes, clear.
Okay.
Clear.
Okay.
Just the answer, doctor. How much would it be?
How much is the answer? I don't know it because let me see if I have calculated it on my slides. But in the solution which I'm uploading, you will see a complete solution there. I didn't calculate it on my page. Okay, but I will upload the solution later on. You can compare with. Okay, so here usually the most of the problem that I have been solving, most of the times the normal force is either from the top surface or from the bottom surface. So the students just confuse the normal force and they think that this normal force always has to be in the y direction. Okay, so now I'm going to remove that confusion by solving this problem. Please read the statement and then we solve this. Okay. Okay. A 12 Newton horizontal force F pushes the block weighing 5 Newton against a vertical wall. The coefficient of static friction between the wall and the block is 0.6. And the coefficient of kinetic friction is 0.4. Assume the block is not moving initially. Will the block move? In the unit vector notation, what is the force on the block from the wall? Okay. So let's set this diagram first and then we attempt to solve this. There is this wall here and the block is attached to it, like a kind of connected to it, okay, like this. And there is an applied force. Applied force is in this direction, okay. This is an action force. So the block surface, the wall surface is now applying a reaction force to it, and that force is going to be in the left direction. So which force is this going to be?
12
The
Newton.
normal force.
That will be the normal force. Okay, that is the normal force. And we also know that this is the weight which is downward. And what kind of force is going to be upward?
Friction.
Friction, because when you hold something against the wall, the tendency of the block is going to come down. So therefore, the friction is going to be upward along the wall, okay, like this. So here at this point, we are just naming this as a friction, and let's put this as a static friction initially, and later on, if you started to find out if the block was moving, then we can say that it will be a kinetic friction. Okay, so the first thing is that assume that the block is not moving initially. Will it move? So when we are going to look for this condition, part A, what should we do?
We should find
12.
the maximum F, maybe.
So here, the downward force is, this is the force which will be moving it. And all we are going to do is, it says that the weight is 5 Newton, right? They are giving us this. The weight is, the block weight is 5 Newton. Now what we are going to do is, we know that the static friction is going to be upward. So I will look for the maximum static friction. If that maximum static friction was more than the weight, then of course the block will move. But if the block will not move. If the maximum static friction was less than this, then the block will move. So Fs max is equal to mu s Fn. Okay, and Fn, we normally got used to it. We are using mg for the Fn. What should we use now for the Fn?
The force on the wall.
The force on the wall. So because these two are balancing, the block is not going in this direction either or that direction. So therefore Fn is equal to F, which is equal to 12 Newton. So the mu s from the problem, it is given to be 0.6.
Yes.
0.6 times 12. How much?
7.2.
7.2 Newton. Okay. So here, by comparing the equation 1 and 2, what we see that the maximum static friction is more than the weight. Therefore, the block will stay in contact with the wall and will be not moving at all. Okay. Then we go to the second part. In the unit vector notation, what is the force on the block from the wall? So can someone tell me how many forces are there on the block from the wall?
One force.
2.
Okay, what are they?
Normal force.
Normal force, Fn, and it is pointing to the left, so negative I. What is the other force?
Friction.
Friction is also coming just because of the contact with the wall. So Fs, and that is going to the positive J. So the value of Fn we know, and the Fs we know. We just put the values of them and the unit vector notation. This is what they are asking for.
I have a question.
Yeah.
Should we use the if S minus the weight of the body as a J component?
No, not because they are not asking the net force on the block. If they are asking net force on the block, then use that, okay? But they are asking the force on the block from the wall. So then you are going to look for the total forces just because coming from the wall, just because the block is in contact with the wall, okay? So then in that case, if the block was not in contact with the wall, then you will not see the friction and you will not see the normal force, right?
Yes.
Yeah, so that's what they're asking. If they're asking for the net, then what you said is correct. Okay, guys, this is a very important problem. This is very confusing problem as well. So let me explain this, and then on this prototype, I'm putting two more problems after this, which I will not be solving. So one of them I'm solving, and the other prototypes, I will be giving you solution, okay, directly. A 60 kilogram block slides along the top of a 100 kilogram block. The 60 kilogram block has an acceleration of 3 meters per second square, while a horizontal force of 320 Newton is applied to it, as shown in this figure. There is a friction between the two blocks. Find the magnitude of the acceleration of the 100 kilogram block during the time that the 60 kilogram block remains in contact with it. The surface under the 100 kilogram block is frictionless. So let's put this diagram first. There is this block. It is in contact with the smooth surface. So no friction at all on the lower surface. This is 100 kilogram. And then there is the 60 kilogram block. Okay. And the force on this is to the right side. Just because of this force, there will be a friction, right? So the friction will be coming in which direction?
Left.
Left.
Yeah, for the 60 kilogram block, in which direction the friction is going to be?
Left.
Left. Okay. So Fs is there. Then for the 100 kilogram block, in which direction the friction is going to be?
There is no friction.
No friction.
No, these two surfaces are in contact. So just because of this surface, how much is the force applied on this? Because
So
when you
to
are
the right?
surfaces,
To the right.
To the right.
Okay, so for this 100 kilogram block, this is going to be the right, and this, in fact, is going to be equal to this one, just because there is smooth surface below this. Okay, so now let me solve this problem, because this block is going to the right side, and here we say that the top block is accelerating to the right. So F is the force on the right, Fs is the force on the left, and then as a result of that, the block 60 kilogram, let's call it A, and this B. So block A is accelerated by acceleration A. And also I'm putting the acceleration A just for distinction. Okay, now we are going to look for the forces. Do we have all the forces? And also there is while the block is okay. Okay, so here we know this force, we know the block, mass of the block, and we also know the acceleration of the block, right? So just because of this, Fs is going to be, I'm just moving this, isolating this to the right side. This will be F minus MAA. So we know the value of the force which is given, that is 320 Newton minus blank of mass A, which is the 60 kilogram, and the mass of black A, yes. And then the acceleration is 3, right?
140.
This is 180. What we get? 140?
Yes.
Okay, 180 Newton force, we got it as a static fraction for this. Now, on the second block, since this is the only force that is acting on it, so therefore, this is the confusion point here, okay? The friction force, the static friction force is acting on it, and it is trying to accelerate the block mass B with some acceleration B. So I'm going to divide both sides by B. It will be Fs divided by MB. So 140 Newton divided by 100 kilogram. So which is giving me 1.4 meter per second square. This is the answer I'm getting. What is the confusion here? The confusion is right here, the student consider that the fraction force is not applied to one block. They're taking the two masses. That's one thing. Second is that here for the blocks, for the 60 kilogram block, when they consider the direction of the fraction, then they consider the same direction for here for this block, which is not true. Because when you are rubbing the two surfaces, and if you are moving the top hand on the bottom one in the forward direction, then you see that you are moving the lower direction, the hand in towards you, like in that. So therefore, the fraction with respect to the two blocks, the same fraction will be in different directions. Okay.
I have a question.
Yes, yeah.
Why is it static friction? It's not kinetic friction.
Well, here we didn't specify whether it's kinetic friction or static friction. I put the static friction because the assumption that it was just sticking at the very first level. Okay, that's assumption I went with. Later on, I find out that if the block was accelerating with respect to each other, because the acceleration of this is definitely different than the acceleration of this. So then I can change the sign of the static friction by kinetic friction. So in reality, these two fractions are exactly the kinetic fraction. But since we didn't come up to them from using the kinetic friction formula or the static friction formula, therefore we got the same answer. Right? Okay. There is another, guys, this is another problem. It is again on the blocks. I solved them and I put the solutions right there like this on the slides. It will be uploaded. You can look at that. The concept is the same. There is this another problem. Now the two blocks are attached with each other. I'm just resolving the forces for them because I not even have time for that. But what is happening that when you're block 2, you are moving it to the right side. You know that the M1, just because they're connected with single string, so the M1 will go in the left side. So instead of fractions now, you have the tensions as well. So then again, I also resolve the forces for them and then put them together like this in the solution. So you can look at them. So let me go jump into the circular parts. Like there is this car, and it is going in a circle like this. It is a vertical circle, not a horizontal one. So a small car of mass 0.75 kilogram travel at constant speed on inside of a track that is vertical circle, as shown in this figure. If the normal force exerted by the track on the car when it is at the top of the track at point B, that is 5.5 Newton. What is the magnitude of the normal force at the bottom of the track at point A?
I'm sorry,
So,
Doctor. Do you mind
yes.
explaining
Yes.
What does vertical circle mean?
Yeah. So Let me explain this. Like when you go in the normal roads, in the roundabouts, right? This is the horizontal. It's just the circle is, but it is sitting on the ground. Okay, so that is called horizontal circle. When you have the circle like this, you move up and down like that, away from the earth and become back to the earth like this. So that will be the vertical circle. You got it?
Yeah. Thank you.
Okay. So to analyze the forces, first of all, like this, have the circle, put the block, and consider this is a point B. And here again the block, which is the car there, and point A. I'm asking the help from you guys. Tell me, what are the forces that are pointing upward and how many forces are pointing downward at point A?
At point A, we have the weight.
Okay. Downward. Okay.
And then we have the normal force.
Fn
Fn is in which direction?
upward.
Okay. And then
Force to the center.
And force to the center, centripetal force. So that will be the mv square or r.
Yes.
These are the forces right here. And when we are here at the top, how many forces are downward?
Same.
Okay. Fnb, which is the normal force, and then mv squared by r, which is also down. And then what else? What other force?
mg.
And
Down.
which direction?
The weight.
Downward.
Downward. So
Yes.
all three forces are downward right there. Okay.
Yes.
Note when I use the Fn, I didn't use only Fn here and here. I say Fna and Fnb because the normal force at 2 points are different. So let's put all forces here. Negative Fnb, negative mg is equal to negative mv squared by r. When I'm putting the forces for this, it will be positive Fna, negative mg, and then I have positive mv squared by r. Okay, now we look at the problem and what are the things that are given to us. If we don't have the information regarding something, we will eliminate. Do we know radius?
No.
And how about the speed?
No.
Okay, so two things we don't know right here, and this is the trouble point. Let's eliminate this. Add the two equations so that we can eliminate that. Fna minus Fnb and minus, so minus 2 mg, and right side one is plus, another one is minus, it cancels out. So they're asking what is the normal force at point A, because the normal force at point B is given and m is also known. So Fna is equal to Fnb plus 2 mg. So I just put the values, which is 0.55 plus 2 times 0.75 times 9.8, and it will give us the normal force up there. At the point A.
I have a question, Doctor.
Yes.
Is there any centrifugal force?
Centrifugal force is always there, but regarding the centrifugal force, it is called fictitious force. Okay, so usually you cannot structure the centripetal force. It is happening just because of the circumstances.
And they have another question.
Yes.
In the point B, should the car go down?
Right here.
Yes.
It will not if the speed of the car was much smaller, right? If the speed of the car was much smaller, then it will fall down, right?
Okay.
And then if it was much faster, then it will affect the centrifugal force and will still stick in the surface. Just because of that, there is the normal force. So the normal force is the indication that the car applies sufficient force on the surface and the surface is applying reaction force as a result. If we see that the normal force at the upward side right there was 5.5 and that is positive, then we are saying it is really there is the force.
Doctor?
Yeah.
From where we got mv square divided by r? It's the
it is the centripetal force.
Oh, yeah.
Yeah, it's a centripetal, like the Newton's second law, F equal to ma, but just the shape of the A is v squared by r. Okay, is this second problem, guys. This one, let me see if there was any different problem that I can solve it. If not, this problem is again the same, like you are having the two normal forces the same way at the two locations, but instead of in the circle, now you have the two different locations and where you have this problem. So I have a lot of problems collected, but let's solve this one because it is different. And this will give us a little bit different flavor to you. A box slides down a rough inclined plane at a constant acceleration of 0.2 meters per second square. The inclined plane makes an angle of 12 degrees with the horizontal. What is the coefficient of kinetic friction between the box surface and the inclined plane? And ignore a resistance in that case. So there is this block and the angle is 12. Okay. And it's slide down a rough inclined plane. So the acceleration is this direction, is in this direction. So obviously the fractional force is upward and that fractional force is Fk, kinetic friction. So we want to determine the coefficient of kinetic friction here. Again, since we have these two forces now, we also know there is this weight of the block, and the block weight is going to be divided in two components, mg cosine theta, and here mg sine theta. These are the two components of that. And as a result of the mg cosine theta, there is this Fn. Okay. Now let's start resolving the forces along the plane and vertical to the plane. So this is the XY diagram that you are going to use, tilted coordinates. Okay. So consider the Fk is positive, mg sine theta is negative, right? And then the block is sliding downward, so that's also negative, ma. Here from this, let me bring in the Fk equation. So Fk equation, you already know it is mu k Fn, right? And the Fn we need to determine it from here. So this Fn, from this diagram, we have Fn upward and mg downward, and these are balancing each other. So mg cosine theta. So what we will do, we will just put that Fn here, mu k mg cosine theta. And if this is equation 1, this is 2, then equation 2 and 1. So mu k and mg cosine theta minus mg sine theta is equal to ma. So you guys know that the m is appearing too many times, and also the mass of the block is not given to us. Okay, so therefore we are going to eliminate this. Like the m, from here we take it common, we cancel it from both sides. We like as if we are dividing both sides by the m. Okay, so this is our equation which is left. Furthermore, we need to look at the variables if we have all of them, right? So the mu k is our target that we want to determine, right? G is constant, theta is 12 degrees, that is given. G is constant, theta is again known, and the acceleration is known. So since everything is known now except mu k in this equation, then we can solve that for that. Just, I'm open to your question now. Yeah, Yazid.
Doctor,
Yes.
I have a question.
Mhm.
If ny is equal to mg cosine, isn't it the negative mg cosine?
It is negative mg cosine theta. I took this step a little bit direct.
So
No,
it's
normally
negative
what I do, yeah, normally what I do is the Fn minus mg cosine theta equal to 0 because the black is not accelerating up and down, right?
Yes, yes. Yeah.
And then the second step will be there, like which I was showing.
Okay.
Yeah. Any other question? Okay. So with this, I'm stopping and also asking you guys that first there will be a homework open for you, which is about the chapter 6 that is due on Saturday night at midnight. So you can work on that. And also in next week, do you want the quiz to be in chapter 6 or chapter 5? Which chapter do you like?
5.
5.
Chapter 5. I think 5 is better.
Okay.
6.
Chapter 6. Okay. So let's vote on this. Just okay.
Doctor.
Raise your hands if you want the quiz to be in chapter 5. I'm getting 4 hands now. It's 27. Okay.
We have 45, Doctor. 48.
48 I got. Okay, so chapter 5. Yeah, you got majority. Who is the president now?
Doctor, I have a suggestion.
Okay.
How can we have exam math and then physics in 2 days midterms? We are not human like this. We're not robots.
Guys, this is I have all my sympathies with you. I do understand it is a tough thing, but this is not in our control. We don't have any say in that. The midterm exam and the final term exam, these are fixed from the university side. We just need to arrange it.
Yeah, Doctor, because
yes.
it is a new term and a new way of studying, you should be making it easier for us, not even harder. We are studying in stuff that we had never done before. 20 years we're studying face to face, and then all of a sudden you say computer and you make it even harder.
Meshari, if I was, let me say it. If I was doing it, I will be exactly going with the students' consensus. If the students want it in some other weeks or at the start of the week or something, then I could arrange this. But as I said, midterm and the finals, these are the kind of exams which no one has any say in this. And you will not believe that usually we get in the situation that the students come out of one exam and just get into the next exam, just with a half an hour or 1 hour break between them. So these are the kind of situations we don't have any control in that, and probably the universities can arranging it. What they know is the best solution for this at the moment.
Doctor.
Yes.
Nick, can you make the quiz multiple choice? Because in the previous quizzes, it's always if it is 3.1 and if I write 3.2 or 3.3, just it's making it wrong.
Yeah, so Suleiman, whenever you are writing like a 3 point, if the 3.1 was the answer and you write 3.3 or 3.4, in all of the answers, I provide the flexibility of 5% error. So if your question is falling in the 5% error, you will get full points for that. And after that, whenever you guys give the quiz, after the take the quiz, then after that, I go to the blackboard, check all the quizzes one by one. And I honestly provide the points to all the students, which I feel that there is any offset a little bit. Then I provide the points. After that, if I didn't catch up some errors and the students complain to me, I work on that and also provide my feedback to the students. So if you have any concern at any point, ask me and I will be helping you then, okay? So I'm not the kind of person who will be taking your points. That you deserve the points, you will get them. But the thing which I'm a little bit, sometimes get a little bit upset, the students, they put their complaint, I work on their complaint. I set their grades to the correct grade, what they deserve, and then they start in the arguments that say, teacher, please give me 0.2. No, I cannot give you 0.2 or 0.1 or 0.3. If you don't deserve, you won't get it. No matter how much you are asking me or arguing with me, I will be giving you what you deserve, and that you will get all the time like that, no matter what.
Teacher,
Yes.
I have a question. You said today we have a homework, chapter 6.
Yeah.
I checked Wiley Plus and it says it's due 3 days.
It is not today. I said it will be open.
Okay, then I have another question. Can you open the attendance form?
Why?
Because I tried to attend myself. I joined 12 and the form logged me out. I don't know why. I tried to log back in, changed my password, and after I did all that, the form was closed.
Okay.
Me too. When I was talking to you about the midterm, I forget to present myself.
I didn't want to interrupt the lecture. I typed in the chat, but you didn't see it.
Okay.
Doctor, can I leave? I have another lecture.
Sure. Anytime. The lecture is over. You can leave anytime. Just go ahead and submit your response now.
بس هلا.
Doctor.
Thank you, Doctor. Have a nice weekend.
Okay. Yes.
Doctor, the midterm, is it will be focusing more in the last 4 chapters, and the first 4 chapters, it will be 4 or 3 questions just?
You did they announce like how many questions will you get in the midterm?
Not anything.
Okay.
They just said 25 questions from chapter 1 to chapter 8.
25 questions?
Yes, or 20. I'm not sure.
Probably 20 questions.
Doctor.
Yes. So that is I think it will be based on the number of points. If you have 25 points allocated for the midterm, then you will get the 25 questions. That's what I believe that will be the pattern. I didn't see any announcement from their side yet, but I'm expecting that the focus will be more on the later 4 chapters rather than the first 4 chapters. But though they will cover, like normally when we have only midterm without any coordinated quiz, then the focus remains on all 8 chapters equally. I will see if I can find any information for you guys and share that with you. Yeah.
Doctor.
Yeah.
The next quiz will be on chapter 5.
Yes, chapter 5.
On Monday or Tuesday?
That will be on. Monday. We have recitation, right?
Yes.
Okay. Do you want it on Monday or Tuesday?
Whatever
Tuesday.
you like. Tuesday, Monday, whatever you like.
Okay, so let's go for the Monday.
Okay, that's fine.
Okay. Yeah.
Should I do the attendance again?
No, if you did it once, then you don't need it. You did it at the beginning?
Yes.
You don't need it. Yeah, you guys, if you want to leave, you can leave anytime because the class time is over. If you have any question, you can ask. Yeah.
Thank you, Doctor.
Yeah, no problem. Ahmad, your hand was up there and you dropped the hands. You had a question for me?
Just regarding Wiley, Doctor.
Uh-huh.
I was the one who messaged you about the 1.2 being 1.3.
Oh, no, I know you. You're a very good student, and I trust you. No worry. No worries. This was just a general example. I didn't even mention you. Like this is happening all the time.
Yeah. That only that on Wiley. So if you could fix that.
No worries. Like if you think anywhere in any quiz in any assignment you got points but you deserve more, contact me and I will be looking at that, and if you deserve any points I will be adding that for you.
Sure. Thank you, Doctor.
Doctor, the policy of created change after.
Yes. Yeah.
So
the
when
policies
they apply.
The policies is changed. I will be looking at the updated policy which the course coordinator has sent us, and we'll be uploading that on the Blackboard. Yeah. So you will see. Yes. Yeah. So, but whatever you see for the Physics 101, if you hear from other students, the Physics 101 policy is the same for all Physics 101. So we don't actually change from one coordinator to another instructor, right?
Doctor, the next midterm will be 25%.
In policy, I believe that's what they have mentioned, but I will upload that. Okay, I will upload that information on the Blackboard. You will be able to see it hopefully in half an hour from now.
Okay, thank you.
Yeah, no problem. Abdulaziz, yeah, Musab.
Doctor, I want to ask you about the last quiz.
Okay.
I sent my response in the last minute.
Okay.
Approximately 10 seconds before the end of time.
Okay.
And I got late.
Yeah, so the late message usually you guys get when the system sends the due date, the due time as well, and also the availability date for the quiz is fixed at single point. So if you get the late message, that doesn't mean anything.
But I got 0, and I think at least my first question is true. My answer on first question was true.
So okay, so send me your. Is there any other student who wants to have any question? If they have any quick question, then I can work on that. Otherwise, I will work on your Blackboard assignment. Amjad or Abdulaziz or Abdurrahman, do you have any quick question? Okay, Musab. So, what is your section number?
My section is 28.
28. Okay. Okay, and just 1 second. Okay, and give me your ID. What is it?
2020. 26.
26 and 140.
Yes.
Okay, so this is the quiz 3. Attempt. Okay. On your personal chat, I'm sending you the solutions. Look at this.
Okay.
Yeah.
Oh, okay.
Yeah.
Thank you.
Yeah, no problem. Okay, so it looks like Abdurrahman and Abdulaziz are not there, right? So I'm leaving the meeting.